Answer the following. A. The casing of a rocket in flight burns up due to friction, at whose expense is the heat energy required for burning obtained, the rocket or the atmosphere. So here the heat energy required for burning, that is obtained due to fuel. When fuel is burnt, we get the heat energy. So when fuel burns, then the mass of fuel decreases. So in that case, we can say mass of rocket also decreases, right? So we get it at the expense of the mass of rocket. Then B. Comets move around the sun in highly elliptical orbits. The gravitational force on the comet due to the sun is not normal to the comet's velocity in general. Yet the work done by the gravitational force over every complete orbit of the comet is zero. Why? Because gravitational force, that is conservative force. And in case of conservative force, the work done depends only on the initial and final position. So when the orbit is completed, initial and final positions are same one. Or in other words, we can say when the orbit is completed, it forms a closed loop. So work done over the closed loop in the case of conservative forces, that is always zero. Then C, an artificial satellite orbiting the Earth in very thin atmosphere loses its energy gradually due to dissipation against atmospheric resistance, however small. Why then does its speed increases progressively as it comes closer and closer to the Earth? When it comes closer and closer to the Earth, then height of that satellite from the surface of the Earth decreases. So its potential energy mgh also decreases. Total energy that remains constant. That is kinetic energy plus potential energy. So if potential energy decreases, then kinetic energy must increase, then and then only the total energy will remain constant. And therefore, its kinetic energy increases, which cause in the increase in its speed. D. In figure 1, the man walks 2 meters carrying a mass of 15 kilogram on his hand. In figure 2, he walks the same distance pulling the rope behind him. The rope goes over a pulley and a mass of 15 kilogram hangs at its other end. In which case is the work done greater? See, in this first case, the displacement is in horizontal direction and the force of gravitation, that is downward. So both are perpendicular, so work done is zero. In second case, when this one is moving in this direction, so we can say the pulling force by man is on the rope and that is transferred to this object. So on the object, the pulling force in upward direction, and when this man moves by 2 meters, so this object will also move in upward direction by 2 meters. So the height of object is changed by 2 meters. So change in potential energy, that is mgh, and that is also equal to work done. So in this second case, work done will be more, and we can calculate it as mgh. M, that is 15, g, that is 9.8, and h, that we have to take 2 meters because this man move in this direction 2 meters, then block will rise by 2 meters. Clear to all of you? So this explanation is given to you on this particular second page.